Welcome to TAM. Now, this TAM version is TAM 2.0.9, and we did a lot of feature upgrades in TAM 2.0. It's a great piece of software, but what we're going to do today is we're going to take a basic fluid level shot.
Welcome to Local Energy. My name is Peter Brecht. I'm here with my co-host Wade Spear, and we're joined today with Justin Bates from Echometer. This has been a long time coming. I'm so excited to talk. Echometer was mentioned in one of our very first podcast episodes, and I'm just so happy to talk. Justin, thank you for being here. How's things out your way today?
Man, everything is good. I got to be honest though. Over Christmas, we had a nice 87 degrees, 85 degrees. Today, we're sitting down at 39. So good. I'm cold.
Where are you at? Where are you located at, Justin?
So Echometer is actually located in Wichita Falls, Texas. So we're about 2 hours north of Dallas and about 2 hours south of Oklahoma City, right near the Red
Okay.
River. We're kind of
All right.
right in the middle of Dallas and Oklahoma City.
I'm up in Tulsa. We had the
Oh, okay.
exact same thing, but I didn't know how far south the cold front reached.
Well, it got us yesterday. All the leaves that I had raked up in the front yard have now blown to the neighbors, so we're good.
Yeah.
I saw somebody raking leaves, and I was laughing. I was like, "Oh, like you're just gonna catch all your neighbors now."
Yeah, absolutely,
Mhm.
absolutely.
So for those of us in the audience that aren't sure what Echometer does, can you give us kind of a high level on the company and what you all are doing?
Yeah, absolutely. Echometer was originally started by a gentleman by the name of Jim McCoy back in 1962. So Echometer has been around for a very, very long time. And what Echometer originally started out as is a manufacturer of acoustic fluid level instruments. So acoustic fluid level instruments, what I mean is that we actually take a measurement from surface and we generate an acoustic wave down a wellbore in which to be reflected so we can determine the distances to blockage, such as at the top of a liquid level. Now, what's kind of funny about
Hmm.
this is whenever this first started, a lot of people don't realize this, but a lot of these measurements, the acoustic wave was actually generated with a 10 gauge blank or
Right.
a 45 Long Colt. And so that's the way we were generating these acoustic waves as they would travel down the wellbore to be reflected. And then we were actually able to record it and determine distance to the liquid level by means of knowing the acoustic velocity of the traveling wave. So, Echometer got their start in acoustic fluid level measurement. And today we manufacture all different types of portable sensors from dynamometer sensors. We actually can use the Echometer equipment to track plungers and plunger lift wells to determine, the fall velocity of the plunger through the gas when it hits liquid, when it's on bottom, to optimize just the overall performance of the plunger lift system. So Echometer does a lot, and the sensors, you can do a lot with them. What all started as the acoustic liquid level game has definitely grown into a full suite of sensors for portable optimization and troubleshooting.
One of the most common thing that I've heard about your company is just the level of service that you provide is just incredible, right? It seems to be, everyone that I've come across in the comments or that I've talked to about your company, anytime they call or have a challenge or, hey, this is something I'm coming up across in real life, they pick up the phone, they call you, and someone's like there to walk them through it or help them figure it out. I just think that's incredible. I mean, is that something? It must be something you guys are like. I don't know. It must be like a tenant, a core piece of your company. Is that sound about right? I don't know if I'm off base, but it seems to be the case.
No, it absolutely is. Everyone that is here to serve and to answer questions for customers, all of us have an oil and gas experience, a background. Most of us have spent more than 10 plus years in the field. And a lot of us, part of the reason why we provide such on top of like over the top support is because we've been that guy that is in the field. And honestly, where do I tie this gun in at? What is this telling me? We had all those questions ourselves and we were able to rely on ones that came before us to answer those questions. And so, each one of us have a have a desire and a quest for knowledge. And the day we stop learning, the day we stop attaining knowledge is the day that we die. And so we want to be able to provide that to our customers. And the biggest thing that I always tell our customers, and part of the reason for our customer support, is that don't ever let this fancy equipment supersede your conventional oil field knowledge. Let's learn through the process. Let's understand what exactly is going on. And so that way we can help you become a better operator of the equipment. Because at the end of the day, if you're an excellent operator, you're providing good data, then that is good for you and Echometer alike.
Hey guys, thanks for listening to this week's episode of Local Energy. Please remember to like and subscribe to us here on YouTube or Spotify, or check us out at localenergy.com. All right, back to the show. Are you guys still learning? And I'm sure we're always learning, right? But are you still developing the product as you go, or is this product something like, okay, this has been built, it sort of works, it's kind of static, or are you guys adding new features? Tell me a little bit about that, maybe.
So we're always developing in the software. There's so many, there's a laundry list of items that we're always trying to add into the software, such as within the past 2 years, we've added in the dual shot module. And so there's a lot of things that we add into the software. As far as the hardware is concerned, it's not static because we continue to develop and enhance. But as far as the overall basic physical premise, it is pretty much static. But the main development comes through the software.
Okay. Gotcha.
One question I'd have is like in terms of the application of it. I always talk about fluid level. Can you also see other things downhole? Like say that you purchased a well from another operator. It's been shut in for however long. You don't have good like a wellbore diagram on it. Can you see here's where top of fluid level is? That looks like there might be a packer down here. Like, can you see all that different stuff with the travel?
So part of this is that, the total blockage is the total reflection. And so with that being
Okay.
said, if the acoustic wave travels down the wellbore, reflects off the blockage, that's the extent of what you're going to see. Now, if the
Okay.
liquid level is low in the well, let's just say that, you purchase a field from a previous operator that did not keep good notes, and you've got low liquid levels. You shoot an acoustic liquid level, anything that changes cross-sectional area in that wellbore is going to reflect that energy back to the source. Very similar. Our technology works very similar to such as sonar and as well as radar.
Right.
And so you can think of it as this traveling wave. A portion of it gets ripped off and sent back to its source. And so we'll use a liner top for an example. If the wave reflects off the liner, that is going to travel back to the microphone while the main portion of the wave continues traveling to the distance of the liquid level, hits the liquid level, and then it's got to travel back past the liner again. And so with that being said, a basic study of the acoustic trace is going to give us the reflections to understand exactly what's down in the wellbore, to have an idea of just being able to see with an acoustic sound wave.
I got you.
It's amazing. That is so cool. Like who knew that you could do that much with just sound, like it's impressive.
We do get the question quite a bit is that, well, can we see oil water interface? No, but if we could, I probably wouldn't be sitting here.
Yeah.
The top of the liquid is the total blockage. And that's the thing that I
I
always
got
tell
you.
too, is that just because a total blockage, that doesn't mean it's liquid. Heaven forbid, it could be collapsed casing, it could be a sand bridge, it could be a salt bridge, it could be anything else. And
Right.
like some of the premise that we try to push to the guys that are learning to operate this is that what's the only thing in the wellbore in the casing annulus that should be moving with applied pressure or removing pressure? The liquid level. And so with that, the premise is move it to prove it. So that way you can determine based on the time to the reflect to the blockage and back, if it's moving as you add pressure or take away pressure, you know that it's the liquid.
Okay, so they say there's no such thing as a dumb question, but I'm going to ask what I feel is probably a dumb question. There's vertical and horizontal. I'd imagine this only can measure the vertical portion of a well because I'd imagine the fluid raises up to the vertical portion, or how does that work in terms
So
of like, horizontal wells?
it's pretty interesting. So this wave doesn't care whether it's vertical or horizontal. It's just reflecting off the changes in cross-sectional area. Now, typically with a horizontal well, the liquid is going to build in the heel, and so that is your total blockage. But in reality, if there is the pathway for that wave to travel through gas, that wave will continue traveling. I've absolutely seen wells that were on production. I'll use a gas-assisted plunger lift well that I've seen recently, to whereas we had stratified flow where there was liquid down in the bottom of the lateral, but at the top it was still gas. And so that acoustic wave was able to travel through the gas, past the individual gas lift mandrels, past the end of tubing, into the lateral, and then it reflected off of the portion of the lateral where it was a down dip and a gathering of liquid in the lateral. So as long as there's a gas median for that wave to travel and there's enough energy, that wave will travel.
Okay, so you're getting this data back, this information back. What are some of the activities that would occur after? Like, what are the action items or the laundry list of things that, okay, now I need to do these? Like, what are the remedies? Or is it just more of a like a health check that you'd be doing with this tool?
It really depends, to be honest. And so the way that I always break this down, and coming from a history in this, is that I always break down my Echometer analysis into two different buckets. I may have one bucket, which is my health check. It's my routine. It's just making sure that things are optimized, things are running the way they are, and the way they should be. But then I've got my troubleshooting tool. Now, the idea with the optimization, the checking in, the health check, is that you want to analyze the well when it's in its normal production state. Okay. If the well is running, let's just use a rod pump, for example. If it's running 24 hours on hand and you shoot the liquid level with the pumping unit running, you want to know what its producing state is at. And so that way you know how to optimize based on that. Now, if I'm troubleshooting a well, then that's when the state, such as running or not running, really goes out the window for me. To whereas now I'm going to try to change the condition of the liquid level based on what I know and how fluid is going to react with pressure put on and taken away in order to prove what I think might be going on with the well. And so, most of the time, and I can't speak for everybody, but I do break my shots up into those two buckets to where I'm optimizing, I'm doing a health check, and then, hey, I have no production to surface. Now we're going to get into troubleshooting and changing the condition of the well, and then using the detailed data to validate what I think might be going on or to disprove what I might think might be going on.
I think we should dive into, you have this object behind you. I'm not sure what I'm looking at. It looks like a bunch of PVC pipe or something that I'd probably tie together in my backyard, but it's probably a little more advanced than that. So could you walk us through what this is? I know you have something you want to share on your computer as well.
Absolutely.
Maybe a little bit of background on this.
So one of the things that I'll start off by talking about is that, Echometer, the hardware actually works and is integrated with a software that we developed with some partners. And so with that being said, the TAM software is the software that the wireless equipment communicates through, and that's what we're going to be showing today. Now, Echometer has various different sensors that you can establish on the wellhead with various pressure ratings. Obviously, we're not going to go and put a low pressure sensor on a high pressure well. So it's important to know what you're getting into. And so that way you can use the correct sensor. There's a few things that we can talk about how sound travels through a median, high pressure versus low pressure, but we'll get to that in just a second. So first thing that I'll kind of preface to this is that the Echometer software TAM is actually free to download. Anybody can download it from the Echometer website. And so the idea is that your team, anyone can download the software, but the license to acquire the data lives inside the wireless base station. And so the individual that's out in the field, he has the ability to tie into the wireless base station, tie into TAM, gather the data, and then he can export that data to other TAM users within the organization. And they can share data, cuss and discuss, go through and decide what needs to be done with the analysis. And so the TAM software is free to download. And so what I'm going to go ahead and do for you guys today is I'm going to take a fluid level shot here in the office. Now, obviously, we're not going to take a very big fluid level shot. So this PVC contraption doesn't blow. But with that being said, what I'm going to do is I'm going to start out by sharing my screen, and we are going to open up the TAM software. Now, welcome to TAM. Now, this TAM version is TAM 2.0.9, and we did a lot of feature upgrades in TAM 2.0. It's a great piece of software, but what we're going to do today is we're going to take a basic fluid level shot. Now, one of the things that I'll tell you about the Echometer software is that it really is, I say garbage in, garbage out, but you really get what you put into it. And so prior to going to the field to acquire data on a well, it's important that you go in and actually build a well file. And so you can see over here on the left-hand side that I currently have one of my older wells, which is the Arnold 51 here, and this is a rod pump well. You can see your casing, you can see your tubing, you can see your rods, seating nipple, tubing anchor. There's a lot of things going on, but the idea is to build that wellbore profile representative of what's in the well, because as we established earlier, everything that's in that wellbore that changes cross-sectional area is going to reflect a portion of that wave back to surface. And so the more you know, the better the analysis. Okay, especially when it comes to determining acoustic velocity. Now, what we're going to do today is that I've gone ahead and I've tied in my wireless base station, this is essentially the traffic cop, and this is what's going to be communicating with the sensors that are on the wellhead. And you can see that I've currently got a base connected, but no sensors are connected. And so if I go up here and click on Setup Hardware, drag this over, we've got our base connected, and I'm going to go over to the wellhead and I'm going to turn on the remote fired gas gun. Now, this particular gas gun is rated for 1500 PSI. And so this is a lower pressure gas gun. Okay, go ahead and put it on. And this communicates on a signal that is very similar to Bluetooth. And so the range typically is a line of sight 400 feet that you can reach out and touch any one of these sensors. And so you can see, just like you're pairing your phone and your vehicle via Bluetooth, it remembers that particular sensor, and we're able to make the connection after it's been paired as a friendly. Now, there's a lot of things that we can do with an acoustic fluid level measurement, but one of the things that we always do prior to taking a fluid level measurement is to take a zero offset on the pressure transducer that's installed inside the gas gun. And the reason why is that we do take a pressure measurement during an acoustic fluid level measurement. And so what I'm going to start out by doing is I'm going to simply isolate my well, and I'm going to open the bleed valve side of the gas gun, where the pressure that is represented inside the gas gun is equivalent to that to air. And so I'm going to have no pressure on the gas gun. And what I'll do is I'll come in here and I'm going to perform a zero offset, and I'm going to establish a new basis of 0. And so we can see is on the screen, our new 0 is going to be 1.3 PSI. Typically, we recommend doing this at least once a day, but it was a common practice for me. Each well that I went to, I would go ahead and get a new 0 offset just to make sure that my data was correct and valid. Now I'm going to go ahead and click on Use Shown Value and select that. And now we can see that we've locked in our offset. Here's the new date and time that the 0 has been established. And I'm simply going to X out. Now, when we go to select and shoot a fluid level, we're going to first of all make sure that our proper well is selected. Okay. We're going to make sure that our gun is selected up here on the top of the toolbar. You can see remote fire gas gun with the green check mark. And what I'm going to go ahead and do is I'm going to go ahead and pressure up the gas gun and prepare to take a shot. Okay. Or release the differential pressure from the gas gun into the wellhead. Now, there's different things that we can talk about. We can talk about an explosion shot, and that's what we're going to do today. And the idea of an explosion shot would be to put more pressure on the gas gun than we would have on the wellhead. That way, we explode, releasing that compressive wave into the wellbore. And so if I had 100 pounds on my wellbore, I would ultimately want to put about 250 to 300 starting pounds pressure on my gas gun in order to release that shot and send that compressive wave down the wellbore. So what we're going to do, we're going to take either a CO2 bottle or a nitrogen bottle, and I'm simply going to pressure up the gas gun. I'm not going to put much in it, like I had said, and I'm simply going to close the bleed valve. This is going to ensure that I don't spew gas all over the place or liquid. Now what I'm going to do is I'm going to open the valve between the gas gun and the wellhead. This is ensuring that the wave will be able to travel into the wellbore. And then the last thing I'm going to do at the wellhead is I'm actually going to isolate the backside of the casing, and so that way that wave will travel down in the well as opposed to traveling out through the flow line. And so at this point, the gun is prepared and ready to take a shot. Now, there's two different ways that we can take a shot with a remote fire gas gun. One of which that we'll use today is by simply going up and clicking on Start New Test, which we can see that currently there's no pressure on this wellhead being measured at 0.5 PSI, and we have all of our directions in which we just went through in order to take a shot. Now, one of the things that I want to point out is that this is a microphone inside this gas gun. And so if you're working in a team, it'd be a good time to make sure that your partner is not knocking on the wellhead, as you can see the reflections from banging on the wellhead. And
what are you measuring there on the y-axis?
So that's actually a millivolt scale. And so what we're doing is that microphone inside the gas gun is taking these, and this is cool to me, so pardon me while I nerd out for a second, but it's taking these pressure pulses and it's converting them to an electrical output, which is then therefore the acoustic trace. And so what we're doing is we're able to see before the shot's ever fired, hey, do I need to use more differential pressure in my gas gun? Do I need to go and actually shut down the artificial lift method if it's possible in order to quiet things down so I can take a fluid level measurement?
Okay.
Now, once things are ready once the shot is ready to be taken, we can simply go up to the top and we can click on take shot. You're going to hear the shot go off. There was the shot. You can see the acoustic wave. We're going to mimic a liquid level kick. And then once the shot is complete, what will end up happening is it's going to come back to the analysis window, and we'll be able to go through there and pick the liquid level, determine the speed of the traveling wave to calculate the distance to the liquid level. Now, while all this is happening and you say, wait, there can be more? Yes, yeah, there can. There's a few steps to this actually. And so once we choose our pseudo liquid level, such as this, and what I'm going to do is I'm going to go to a real liquid level. Well, let's wait. I'm going to go ahead and choose my liquid level is right here. And then what we can see in the lower right-hand corner is that we've got a pressure buildup that's occurring. And we've got pressure points that are occurring every 5 seconds. Now, the idea of this actually came probably in the late 80s, early 90s, and Echometer wanted to determine how to calculate pump intake pressure and producing bottom hole pressure from a fluid level measurement. And the way that traditionally this was done was with ways such as a Walker depression test, to where you would add casing pressure to the well and you would push the liquid level down and it would stabilize. You would add casing pressure to the well and push the liquid level down and it would stabilize. But we wanted the ability to be able to do this from a single fluid level measurement. And so one of the things that we do is after a fluid level measurement's been taken in certain wells, such as ESP, PCP, and rod pump, we allow this pressure buildup to run for a minimum of 2 minutes most of the time. And then once the pressure buildup stops, we actually have the ability to determine the percentage of liquid inside the gaseous fluid column based on the buildup in the casing annulus. And based on that percentage of liquid, we can then determine what the height of the gaseous fluid column would be if we factored the gas out of it. And so with that, it becomes not simple, but it becomes a subject of the surface pressure plus the weight of the gas plus the weight of the oil to determine pump intake pressure, and then adding in the water to determine the producing bottom hole pressure.
That seems like magic. That's amazing.
A lot of people consider this the magic box, and I will tell you it is the magic box, but it's one of those things, and I can joke about this, but it's one of those things to where it's the engineer that's fresh out of college that's full of calculations, but it needs some guidance and experience on how to actually handle the analysis. But once you do, it can give you some really good results.
Right. So pairing that with experience is probably the prudent way to handle it.
Absolutely.
Yeah, gotcha. That's really cool. Huh.
One question I've got on the software here is I kind of look second strip from your left over there. It looks like you've got like your Echometer graph. Looks like a dyno card underneath it. Like what are those for different kind of wellbore setups?
Yeah, absolutely. Like I had mentioned in the beginning of our talk, is that Echometer does a lot of different things. Well, one of the things that we do is we also produce sensors that can actually take the surface position and the surface load and generate a surface and downhole dynamometer card. And so there's different sensors that we have available, such as the polish rod transducer, which actually measures the changing diameter of the polish rod through a calibrated strain gauge, along with an accelerometer. And so you simply install this on the polish rod, and then you have the ability to generate these dynamometer surface cards and calculate the downhole card from those measurements. And so dynamometer is something that we can do, conducting valve tests and determining, do I have excess slippage around my plunger in a well based on the valve test. You see CBE. CBE is a counterbalance effect test in determining counterbalance moment on a pumping unit that maybe it's not all Lufkin, maybe it's not all Weatherford, maybe you've got a Lufkin walking beam but Weatherford weights, and so it's a Frankenstein unit. You also have P-lift here, to whereas P-lift is the actual tracking of the plunger and the optimization of the plunger lift process. And then the final one that we have here is advanced analysis, and that's pressure transient analysis.
Interesting.
There's a lot of different modules for a lot of different uses.
Is this tool can it be used like, across the world? I mean, I'm sure is this in every country? Like, are you guys being utilized, everywhere, or is it kind of regional, or
So
because it seems like a very niche product.
And you are correct. It is a very niche product. And so what I've observed is, there are over 100 countries throughout the world that utilize Echometer products. I've actually been surprised at the number of countries that have reached out to us and wanted us to come and teach training. So, you'll see Echometers used a lot, in Malaysia and Indonesia and Kazakhstan, and even over in Europe as well, Africa, you name it. It's a lot in South America as well. And so it's used all over the world. And that was one of the big things that, coming from working for an oil and gas operator prior to coming to Echometer was, okay, if I go to a service company, what's the longevity?
Yeah. Yeah. Are there any like stories you have, maybe just one example of like a project that you've been part of with Echometer that, a client came up against something that they couldn't figure out, and, you were able to kind of, in a sense, look at the data and walk them through, or maybe uncover something. Maybe it took a couple of days, but you guys were eventually able to figure something out that maybe wasn't obvious at first?
Sure. I mean, I really do feel like that's a weekly episode here.
Yeah. Yeah.
Like I said, learning is just a part of the process for every one of us that are here. And so, one of the biggest things that was kind of the aha moment to me was that, I got an opportunity to travel to Saudi Arabia and to shoot and prove the acoustic liquid level process in a well that had lost circulation. And they were wanting to be able to try to shoot a fluid level in this well and prove, hey, where is this liquid level? Because we're just currently drilling our surface. We're not in any producing reservoirs to determine, do I need to pump? What do I need? Where am I at? Is what
Yeah,
it
yeah.
comes down to. So, that was something that I learned a lot on, as being able to go through the physical process of actually closing the hydral, taking the fluid level shot, being able to return that information to them and prove to them as a valid technology. And so, that's one example, but I mean, we do things with people almost every week in the gas lift scenario where they're trying to look for, do I have a bad gas lift valve? Do I have a check valve that's not seating? And being able to use methods such as the dual shot and send an acoustic wave down one path with a gas gun, but listen on the opposite pathway for any return wave that was able to communicate through the tubulars in order to find that point of communication. So that's something I can gladly say that we help people with every week here at Echometer.
You probably have to be pretty familiar with all the artificial lift stuff, on top of what you're doing, right? Because I mean, that's a huge part of probably the world that you're in, right?
Absolutely. Yeah, the experience that was gained prior to coming to Echometer is priceless.
Yeah.
The hard lessons learned and the busted knuckles and everything else, just and not saying, by no means am I saying that I know that all of it, but with that being said, it's priceless information to be able to help customers and learn something each day.
Yeah. What got you into oil and gas personally? Like, is it a family thing, or did you kind of just fall into it?
No, it's kind of funny. My family actually comes from a construction background, and
Okay.
so my family owns and runs a concrete construction company. And my dad, growing up, always told me, you can do whatever you want, but you can't do concrete construction. And but, I grew up, in a hardworking family, and something about the lure of oil and gas and being able to touch the unseen and almost like the unbridledness of, wildcatter kinda always appealed to me as a young man, and, pursuing it through, potentially a geology degree in the beginning, and then kinda changing my course. It's always had that draw, and people say it, and it's true, but once it gets in your blood, it's hard to get it out.
I'm finding that to be the case, especially, yeah. I like my son is going through that phase. He's 6 years old and he's, obsessed with outer space, right? So everything is, wants to learn about rockets and all that. But it's like, I don't know, I in my early 30s kind of learned about, like, okay, there's this whole oil and gas thing, there's wildcatters, there's risk, there's luck, there's a little bit of math. There's this whole engineering side of it, but you don't really know what you're gonna get downhole, right? And then there's meet people like you that are figuring out these cool things where you can actually measure things using, sound waves and all this, which is just incredible. I mean, just is endless the amount of things I'm learning, which has been a lot of fun. And then, get to meet people like Wade too, and just the questions that he asks and things that I get to learn, it's like I'm getting a master's degree. It feels
Yeah.
like it. But what's something in oil and gas that maybe you're thinking about that maybe other people aren't talking about that we should be talking about?
I mean, overall, something that has really stood out to me, and this has all been post-COVID, and at the time when COVID was rampant, I was still working for an operator. And, a lot of times the individuals that are running the artificial lift teams or at the wellhead and they're solving problems, they're your critical thinkers. They're the ones that can think that are thinking outside the box, and I'm just not making this trip past this stuffing box to make sure it's leaking. But what you saw a lot of companies downsizing and then taking their critical thinkers and then putting them back at the wellhead to run routes and to do things and kind of trim the fat, which was a necessary thing to do. But what I see is that often companies forsake optimization and they forsake this picking of low-hanging fruit by putting some of their critical thinkers in different roles in which to not be able to attain the information, that such as Echometer, but in reality, in any software that could be used in this realm could provide. And so that's my biggest thing. I'm really glad to say that I see more and more operators actually taking more of whereas they cut their artificial lift teams, maybe the artificial lift teams are starting to build back to the point to where is a primary focus. And especially with oil at 56, $58 a barrel today, it will become it will be more and more forefront.
Absolutely. Yeah. Wade, any thoughts on that? I mean, I know you're looking at this every day. I'm sure you're seeing something
Yeah,
similar.
I mean, I think I would completely agree with what Justin said there. I think a lot of the times, I've transitioned to kind of smaller operators from larger operators, and I know that I've seen some deals and some packages out there that come from larger operators, and it's just not a focus for them. And you look at those as a small operator, maybe looking to put a little bit of capital out there, and a lot of times you can see some opportunity just because a lot of these companies, the drilling programs and all these are taking tons and tons of the capital, and because of that, they also get tons and tons of focus. Whereas some of these other things are given to some junior engineers, or somebody's overloaded and they've got too much to do on their plate, and so some of these smaller plays aren't being optimized and kept up to speed, maybe the way that they are in somebody else's hands who's really focused on it. So as much, Justin, as I agree with you, I also think, man, that also creates opportunity for other people out there whenever some of that stuff happens. So, yeah.
Understood.
Do you guys think that, I mean, I feel like, a couple of months ago, maybe like a year ago, I would have said like AI, not that big of, like, it wasn't as big of a deal. Like I thought maybe it could have been a flash in the pan, but do you think that AI will allow somebody that specializes in artificial lift, for example, to also specialize in something else and become more of a Swiss Army knife? Or do you think that specialization is still going to be really important? Like, could Echometer, in a sense, like, would you guys be able to, because of AI, be able to expand what you're able to do? Or are you guys going to, I guess I don't want to put it on Echometer specifically, but could you do more because of the resources now with
I will tell you that has been a request from our customers is integrating an AI base so that way, because, with AI, if we could train learning in the interpretation of the fluid level measurements and things like that were typically required a specialist, it prevents them from having to invest the capital to train that person quite as well as they did prior to it. And so, myself, AI is coming. We're going to adapt or we're going to be run over. And so it is something that we're looking into here in the future here at Echometer for sure.
And I mean, but in general, in the industry, like if you have someone that's an artificial lift, like do you think that like individually, like for people that are trying to be, I guess increase their value,
Yeah.
like for myself, for example, right? Like I'm an insurance broker, but my whole goal in life is to kind of like leave a legacy for my kids, right? Where it's like, okay, so yeah, dad did this and dad did that, but he was really good at maybe 3 or 4 things. And I'm kind of finding like what I enjoy doing, what I enjoy talking about, and maybe that's something that they'll gravitate towards. But it's not just one topic, right? It tends to be 2 or 3. Could somebody be good at artificial lift and then also be good at 2 or 3 other things on the field?
I mean, I definitely think the answer is yes, that you've got those people that are out there doing it without AI today.
Yeah. Okay.
Whereas in smaller companies, you wear many hats. You turn a hat a different way, and now you're the measurement technician. You turn it this way, now you're artificial lift. I
Yeah.
mean, they're already doing it. Could they be more efficient? Absolutely. But in my mind, and I'm not a technology hater, here I am, working with technology, but at some point we're just too dadgum busy and need to slow down, take a breath.
Love that answer. My last question, and then I'll turn it over to Wade. But what is your favorite energy drink?
Man, I don't drink energy drinks at all.
You don't, not even
Coffee?
coffee.
I don't drink
Oh,
coffee.
All right.
I am
a
I
rare
am
breed.
wound I am wound tight enough. And if
That's impressive.
you saw me on an energy drink, it just wouldn't end well.
That's
I do
impressive.
drink Dr. Pepper, so that's my caffeine fix. But yeah, I don't
Yeah,
drink
yeah.
energy drinks and I don't drink coffee.
For us serious caffeine drinkers, I don't think Dr. Pepper has much caffeine.
Does Dr. Pepper does it have caffeine in it? I don't
Oh,
even
oh yeah.
know.
I think it's got
Okay.
like I
It's
think
a
it's like
little bit,
It's
yeah.
40,
got
50 milligrams. Yeah.
but
Yeah.
it's not compared to the.
No. I gotcha. Yeah. Okay.
No, no.
No, I don't no Red Bull, no Monster for me. I'm good with coffee, but
Yeah.
I had to ask. It tends to be White Monster is like the leading answer, but
So
that's fun.
I had a kind of on the technical side of things. It seems like, based on the software that you were showing us, what was it? TAM?
TAM,
What was the name of the
total
software?
asset
TAM.
monitor.
Okay. It seemed like that, like the analysis piece was pretty quick. Now, I would imagine though, it's like shooting your fluid level, getting out the location, hooking everything up, doing all of that. It seems like that's probably the longer process. I mean, is that true? I mean, is it, you kind of spend quite a bit of time getting out there, getting everything set up, but once you're kind of ready to fire, is this data come back kind of instantly and you're able to go in and read it within, I mean, because it looked to me like the process was minutes once you got it rigged up and ready to go.
Absolutely. We always recommend that once you rig up, that we're going to take a minimum of 2 shots. For one reason is because we want to be able to replicate the first shot to verify that, hey, my analysis is based on the same result. And so,
Right,
but you're right. Typically, setting up the equipment does take longer than the shot itself because the shot itself is traveling at the speed of sound through whatever
right.
gas medium temperature and pressure is present. And so, with that being said, it goes back to that optimization versus troubleshooting. If I show up to a well and I'm going to be troubleshooting it, I may be there changing the condition of the well for several hours, just trying to understand, trying to learn, shutting it off, starting it up. And then if it's just a routine check, I may go through, hook up the equipment, which may take 10 minutes or so,
Mhm.
take a couple of fluid level shots, and in 20 minutes, I'm on to the next well.
Okay.
Okay.
So it's
Huh.
also that's an interesting, I'm coming from the drilling side. I don't, like I kind of said, don't have a lot of experience with Echometer, but it sounds like it's also kind of an iterative process. So you shoot a fluid level or two, or you take your two measurements. Do you kind of, at that point, you can kind of develop a theory and then figure out a way to test that theory to see, and then maybe increase the pressure or decrease the pressure, all that stuff, and run a few more shots, just trying to hone in on exactly what you think, or is it kind of you go in and it seems like, it's, I don't want to say one and done, but a fairly quick process.
I mean, it can be a fairly quick process, but if you're really
Okay.
wanting to acquire the data to understand, my philosophy is I do my best learning at the wellhead. And so I'm going to stay at the wellhead and I'm going to take this, I'm going to understand it, knowing which method to apply to determine the correct acoustic velocity and determination of the liquid level. I will stay there until I have, an idea of what needs to be done or what's going on. And then, a lot of times too, you'll have the big thing that I always stress to people is that when you're at the wellhead, understand that that's a snapshot in time. Okay.
Right.
I'm there 20 minutes. That's representative of the 20 minutes that I was there. Now, in a very stable well, yes, that may be representative of the well in a 24-hour period. But sometimes it may be necessary to take more data over time to actually understand, how the well's performing. A great
Gotcha.
example that I can give you is that, most of my experience came from the Eagle Ford Shale. And it was our artificial lift practice to initially frack the well, flow it back, flow it up 2 3/8, and then we would gas lift it. But if we didn't have the gas lift infrastructure in place, then we would go straight to rod pumping it. Well, you're going to get into something that we talk about that's called flumping, to where you're pumping it up the tubing, but the well is flowing up the backside. And so you could watch the meter gas trends and you could see when the well was flumping because you saw the gas spike extremely high. and then it would fall off. And so that's an example of how more measurements would help you understand the process. And the example back to that flumping that we've talked about is that, I used to be involved in a lot of root cause failure analysis, and we were having some issues with parting high strength rods and things of the sort. And it came back that under deposit corrosion was our problem. And the issue was is that our chemical that we were injecting continuously was not able to get down and around through the pump and actually coat the rods because the well was flowing it back up the annulus and it wasn't able to get down and around. And so, more measurements gave us the ability to determine, hey, well, no wonder we're not actually treating this well, even though the residuals on surface are showing we have chemical residuals. Yeah, they're coming right back up the annulus. And so we
I
changed
gotcha.
our chemical process to whereas now we're batch treating, ensuring that this chemical is getting down and around, based on what we're learning from the well. I always say every well is like a child. Not one
Yeah.
of them are the same.
That's the truth.
Last question I'd have would be more on maybe the Echometer business side. So, do you guys have hands that you send out, with the equipment to shoot fluid levels, and then do you also sell like the Echometer equipment, the guns, and all that stuff, just to operators so they can shoot, their personnel can shoot their own levels?
Sure. So first and foremost, I will tell you, and it's kind of shocking to a lot of people, but Echometer in itself is its own entity. Even though we're all over the world, our products are all over the world. There's only 18 of us that work for Echometer. So,
I
and that's
gotcha.
to everybody. So to answer the question, do we have a service wing? No, we don't. And the
Right.
philosophy always is that we don't want to be in service because we dominate the market so much. We don't want to be competing with our customers that are out there, such as Scott, that is purchasing the equipment to go provide this as a
Right.
service. We want to be able to provide them as all the support training that they need, but we're not going to compete with them.
Okay. That's interesting because it's funny, it feels like Echometer has such a market share that a lot of times, whenever hear people talk about shooting fluid levels, they just use Echometer. It's almost like
Yeah.
Kleenex, it's
Yeah.
it's a
It is.
tissue, but they call it Kleenex, and so
Yeah.
seems
You are
interchangeable.
exactly right. Those things get used interchangeably, and we really have begun. We are the global industry standard as far as this particular type of device and measurement. There are others out there, but it's one of those things where I can't speak to them because all I've ever used is Echometer.
Right. Right. Gotcha.
Us as a manufacturer, we manufacture the equipment here in Wichita Falls, Texas. We build the software and then we ship it all over the place.
I love it. Justin, you've been so generous with your time. We're well over the mark that I was kind of expecting today. I'm so appreciative of the hands-on demo and just the generosity of your time. So thank you so much. We'll wrap it up here. Give us a handoff. Where can people find you? Where can they find Echometer? And we'll leave it off there.
Absolutely. So you can always find us with us being Echometer at www.echometer.com. Okay. We have tons of free online training resources in our Ask Echometer sessions. Those are all free to watch. I challenge every one of you, for whether you're a beginner or advanced, go in there and watch day one fluid levels. That'll teach you how to hook up the equipment, how to use the basic interpretation, and determining the distance to the liquid level and TAM. It's a good video to watch. And also you can always reach out to me just at justin@echometer.com. I'll be happy to answer any questions that you guys have.
Awesome. Well, guys, thank you so much for joining us here on Local Energy. Thank you, Wade, for being here as well. You guys have a wonderful day, and we'll see you again next week.
Sounds good.
Thanks, Justin.